about nomenclature of nitriles and more nitriles with the nitrile as a group instead of the name of the chain, and lactones and lactams. A lot of good stuff going on here. Greek alphabets here for these two examples and these two examples. Yeah. Let's see what that means when we get there. How do you draw iso-octanonitrile? Remember, nitriles are RCN. Now, if it's a nitrile in nomenclature, here's the tricky part. Students sometimes get tripped up. 1 and then 2 through, I don't know, 2 through X. There you go. A lot of students forget to count carbon number 1. And this brings up a reason why I had to give you a definition of carboxylic acid derivatives. It wasn't during a video, but I'm going to repeat it. A carboxylic acid derivative has a carbon with 3 bonds, 2 more electronegative atoms. They can be oxygen, okay, in which case you get to keep your carbonyl and add another O. They can be amides, keep your carbonyl and add an N. They can be nitriles, they don't even have an O at all, but they have 3 bonds to more electronegative nitrogen. And that's the only real definition. A nice chemical definition is, and we'll learn it later when we do our mechanisms, all carboxylic acids that are derivatives, carboxylic acid derivatives, all carboxylic acid derivatives will undergo hydrolysis to give carboxylic acid. So yes, that definitely proves they came from carboxylic acid. So nitrile, iso-octanonitrile, remember it's going to have 8 carbons and it better have a V on the end. And don't forget, one of the carbons is the nitrile carbon. So let's do that. V, 4, 5, 6, 7, and this is the nitrile carbon right there. I want to verify that's 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And there's your triple C, triple N. Reminder. 1, 2, 4, 6. Uh-oh. Uh-oh. 7. Yeah. It's 8. No, uh-oh. Sorry about that. Okay. Now, when do you use cyano instead of nitrile? Well, when the group is really sticking off of a bigger thing, and it's a nitrile is a C triple N group, and the bigger thing here is definitely cycloheptene. And if that's just cycloheptene right there, and cyano is a group now, so it's no more important than an alkene. In fact, it's less important than an alkene. So we better put a cyano group on here. And you don't have to draw the C. You can start with a single bond and end with a triple. There's a C in there. And it's a stereocenter, so I better see the H, and I need it to be R. So the H will be on a wedge. Nope, sorry, the H will be on a dash. Cyano, not a wedge. Then it goes 1, 2, 3, which is R. Nice. I'm going to do these two and then come back to the lactones and lactams after my computer decides to respond to my save request. Oh, now it's feeling more like my home computer. Yes, there we go. So what do we have here? We have the first one looks a lot like the other one. Don't forget that's carbon 1. This is a nitrile. Those are methyls on 2. In fact, there's 4 methyls in this molecule. 2, 2, 5, 7. comma, tetramethyl, and it's an 8-carbon nitrile again, coincidental, octanonitrile, and it's got a double bond that's got some geometry. We haven't done a EZ review in a long time. We got a 2 for a methyl and a 1 for a CH2 that goes to a C. We got a 2 for an H. We got a 1 for a carbon. The 1s are on opposite sides. That's entgegen. E. If the 1s were on the same side, we know what to do. They'd be Z. Okay. Nice. Next example, the cyano is not part of the longest chain. It's sticking off of a chain, ring in this case. So we're going to call it a cyano. And follow all the rules for nomenclature. In bicyclos, this is a bicyclo. 2, 3, 4, 5, 6, 8, 9. That's an 8 cyano. Oops, we better name it over here. 8 cyano bicyclo. We got a 4 and a 3 and a 0. And it's a non, Okay. I'm always sneaking new stuff in here on you. Non-ene. And it's got a cyano. We already got that. How do you say there's a double bond between 1 and 9? I mean, if it was between 1 and 2, we know how to do that. We put 1-ene. We've never seen what happens if it's 1 and something else because of the bicyclo rules being invariant, immutable. So it's not as hard as you think. You put your 1 like you want to do. And then you say, by the way, it's not 2. The second atom in the double bond is 9. That's a new thing right there. Did I just blow you away? Is it one step too far? Your head just exploded? I don't think so. I think I can handle it. And it's got a stereo center on 6. And the stereo center goes like this. 4. Hello. 4. I believe that would have to be a 1 and a 2 and a 3. And that's definitely not S, therefore R. Can't be S because the 4 is on a wedge. And just to be clear, that's for this guy here. And then we'll get into our lactones and lactams. Let's do it the left way first here. Can you remember this, everybody? Lactones are just cyclic esters. Write that down. Cyclic ester. You have to learn it. It's a new deal. Lactams are cyclic amides. And it's real important that you know they're named after the acid they came from, like these all are. So we're going to draw the acid this thing came from before we draw the lactone. And the acid this came from was tridecanoic acid. Let's draw tridecanoic acid. We're going to do that one down here. Little baby blue. 2, 4, 6, 8, 10, 12, 13. 2, 4, 6, 8, 10, 12, 13. And it's not going to be this when we're done. Delta-octanolactone acid. And I want to remind you something you know already, that this is the alpha carbon, this is the beta carbon. What's next? The Greek alphabet's cut off. It's gamma, it's up here. Alpha, beta, gamma. Use the lowercase gamma. Delta's after that. Gamma, delta, epsilon. Okay, so it's going to be a lactone. So this used to be an alcohol on the epsilon. And that would be, well, why not? Epsilon. He didn't want to draw my epsilon. Epsilon hydroxy tridecanolic acid needs to become R epsilon tridecanolactone, like it says in the name. And we're going to make it R. How about when we finish, we make it R? Right now, we just know this has to be R. I didn't like, that's an unfortunate choice of color there. An R stereo center, but this is not giving me points. I'm not going to do it here. So we're going to have a ring with that O attached to the carbonyl, because that's what esters look like. Water's lost. This is going to be gone. The H will be gone from this. So let's do this. We got the O, and then the carbonyl, and then alpha, beta, gamma, delta, epsilon. Just reminding you. Alpha, beta, gamma, delta, epsilon, and then the rest of the chain, and that contains 1, 2, 3, 4, 5, 6, 7 more carbons. 1, 2, 3, 4, 5, 6, 7. And we're almost done. Stereo center, put the H on there. And it currently is R. If I connect 1, 2, and 3, so wedge H, dash adjacent. And here is an example of a molecule that says there's 13 carbons in it, and the carbons are numbered in the ring and then outside the ring. We've never done that before because it would have been wrong. In the past, we've had groups and rings, and you better have a name for each group and then a name for the ring. And there's nothing in common between the two. Here, the 13 carbons are part of a ring because it came from this thing, which had 13 in a row. Okay. Then a lactam, we'll do that one over here. Same logic. We need a octadecanolactam, so 18. 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's a lot. 2, 4, 6, 8, 10, 12, 14, 16, 18. And yep. And there's an OH here. Why don't we do it like this? Octadecano. There we go. And what's that O stand for? Not a coincidence. Little O. What Greek letter is that? Everybody knows how to say it. For the first time ever, this semester only, any previous semester, nobody have a clue how to say it. It's Omicron. Yeah. Hey, there's two Greek letters that start with O. Omicron and omega. How do you know which one's first? The little one, micro. How do you know which one's last? The big one, mega. All right. And just, in prefixes in scientific units, micros 10 to the -6 and megas 10 to the +6. Kind of cool, isn't it? Millionth versus million. So I'm going to actually try to draw my answer down here. Because I know off the carbonyl, when it's a cyclic amide, you also have to have an N. It's going to look pretty weird. I'm going to put it way up here. And then figure out which carbon in the chain is attached to the N. It's the Omicron carbon, right? So, Greek practice, you ready? Alpha, beta, gamma. I'm going to try my best. This is going to be hard for me. I'm going to write down a couple at least. Alpha, beta. Sorry? No, you'll be given all the Greek letters. But please learn the first 5 for your future. They're not hard. Most of them just match our letters in the English. Alpha, beta, they match, right? Delta matches. Epsilon matches. Learn the first 5. Gamma is the only one that doesn't match. Okay? Learn the first 5. But for anything past that, I will give to you. So it goes alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, z, and then Omicron's right here. That guy hiding over here. He's attached to the nitrogen. Look at that. Look at that. Oh, you're not going to like it. Oh, you like it? Saved me some work, didn't it? We'll make that a stereo center shortly. And what else is on there? Is there anything on the nitrogen? Yes. And carbon 16. I wonder if the Omicron's carbon 16. I think it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's a benzyl group on 16. Oh, and I didn't have, for the first time, I didn't have my reminder, no short forms in part 3. And yes, a couple students. They put F, they put a F there. Don't do that in nomenclature. And here also, you got to show me you know what a F looks like. And a benzyl is a F with a CH2. So we're finished, except the stereo center is supposed to be S, and currently nitrogen. Oh wow, this is going to be weird. You got a number 1 way over here. Sorry. Yeah, 1 and a 2 and a 4. Shouldn't have chosen blue. And a 3. And currently, just pretend the 1's here, okay? Pretend the 1's there, connect 2 and 3. 1, 2, 3 is S. Hey, that's a beauty. You're gonna make a dash for 4. Then a wedge adjacent. And you're done. And the one before Omicron is Z. This looks like an epsilon with a curly tail. Epsilon with a curly tail. I don't know if I did a good job on that. Okay. And yeah, this one's a lactone. It's going to have lactone in its name. Lactone. This one here is going to have lactam in its name. Cyclic amide. You can do Greek or not Greek. I'll even show you a way to do it without the Greek. How's that? Here you go. You ready? 1, 2, 3, 4. And remember, this thing before it became this ring was a long chain where 5 connected to 6, 7, 8. So it's an octanolactone. And it's got a methyl on 7. And it's got a stereocenter on 5. Okay. And that stereocenter is, oh, don't do that. 1, 2, 3, 4. It's S. There we go. And this one, similar story. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's a tridecanolactam with a group on nitrogen that doesn't have a common name. It's a 1, 2, 3, 4, 5 carbon chain. And it's got 4 dimethyl, not gonna fit. Pentyl, okay, it fit. And that's on N. And there's a stereocenter that is, long video, 3. That's a terrible 3. 3, 4, 1, 2. And it's S. Yeah, notice there's not methyl in the name here. Oops. I knew there wasn't room. We needed a parenthesis. Wait, no, it didn't start there. Starts here, right? If I don't have that parenthesis, you're going to be putting methyl groups on carbon 4 here. Those methyl groups are on carbon 4 of a pentyl group attached to nitrogen. So you got to put parentheses. I don't know if they showed up very well. Yeah, they're pretty clear. Parentheses. And there you have that one. And I think that's it. Long one. Ooh. Coming back.